Hello guys, today I'm solving this problem, find the winner of the circular game. So I will tell you first what the game is. Okay, let me draw a diagram and explain what the actual game is being happen here. So in the game what is happening, we are given two variables n equal to 5 and k equal to 2. Okay, so n is the total number of player in the game and k is one number. So what happening here, we will always start the game from the very first guy. Okay, and the game is whatever value k is given to us, we will count that value. So starting from the point where we started, so we started initially from point 1, so k equal to 2, so 1 is here, 1 and 2. Okay, because k is 2, so here we have to remove this guy because this guy is coming as kth element. Okay, now this guy is gone from the game. Now next time we will start from the node which is next to the gone game, the gone guy, right? Next to the in a clockwise way. So this guy is on the clockwise way. So we have to start now our game from here. So again we will count from here. So 1 and 2. So k is ending here, right? So this time this guy is gone from the game. Now we will start from the next guy from here. Okay, so again count 1 comma 2, right? Because k is 2. So now this time 1 is also gone. Okay, let me change the color of it. Okay, now 1 is also gone. So this time what is where we should start? So we will again come to next, but see next is already gone, so no possibility to start. But 3 is not gone, right? So we will start from this guy. Okay, so we will start 1, and what is next? Next is 2, but this is already gone, so we would be here at 2, right? So this time also we would be closing this guy because 5 is also gone now. Now we have to start from where? We have to start, if we go to this guy, this is already done, 2 is already gone, 3 is the only guy which is left with, right? So whenever we are left only with one guy, like in this case 3 is the only guy who is left, so congratulations, this guy is the winner of the game. Okay, so this is all what we have to do, and our approach would be there are two approach basically, so we should understand both approach. First of all, what we will do, let me explain. We can have a Q-based solution. I'll tell you how. So the Q-based solution, what we can do, initially we can put all the numbers, means 5 numbers in this case, into the queue like this, 1 2 3 4 5, and then we will keep the k minus 1 elements. We will remove the k minus 1 element from the front. Okay, and then we will put them to the back of the this queue. Okay, this is actually a dequeue. And then we will remove the first guy after removing the k minus 1. Let's say we remove these k minus 1 element from here, then this guy would be kth guy, right? And we have to remove the kth guy. So if let's say we remove these guys and put them to the back of this queue, and then delete whatever coming to us on the front, like in this case it would be 3. Okay, if k was let's say k is 2 basically, so we would be removing 1 and putting it into the back of it. Okay, so 1 would come here because k equal to 2, so k minus 1 is equal to only one guy, and then on the front it would be 2, so we can directly remove this 2. So our modified q would be like this, 3 4 5 1. Okay, and similarly we would be repeating this process until the q size is 1. So finally we will get the solution of it. So remember, every time we will take the k minus 1 first elements of the queue to the back side of it, and then whoever is kth one, that we would be removing from the list. So in this way, when we will keep on doing, at the end we would be having the when the q size is 1, then that element would be our answer. But there is a problem. If we solve in this way, actually it will take n square time complexity, n into k basically, where n is the size of elements and k is this number, so which is quadratic like n square. So that is not a recommended, though I will write the code for this as well. We should definitely do in both way, but this is not the best solution. We are supposed to do in O of n in interviews. Okay, so we will now discuss that approach. So see here, in this approach what is happening. Anyway, we have to go to kth element, right? Like 1 and 2. So this is kth element. So we have to remove this guy. And if we remove this guy, what would be our new look of this overall diagram of circular thing? This guy would be removed from here, right? And this would be of now n minus 1 nodes, right? So far it is 5 nodes. Now it would become 4 node value, right? Similarly, then again we will call the method, we will start the method from here, correct? From 2 it will be starting, and when we will start from 2, again we will look, right? This is 1 and this is 2, so we will remove this guy, okay? And then our this thing also would be done. So what happened finally? We will remove this 3 as well, okay? Now after removing this 3 as well, what will happen? This will look like this, right? Then again we will start from 4, and from 4 we would be removing 0, correct? So we would, once we will remove this 0, how it would look like? It would look like this, okay? Then we will start from this 2, okay? And then from this 2 it would be, we will start 1 and 2, then 4 will be also gone. So finally we would have this 2. So remember we started 0 1 2. So finally this actual index in the indexing, 0 indexing system, it is 2. So in 1 indexing it would be 2 plus 1. So 3 would be our answer in this case. Okay. So in this approach, this is a recursive approach. Every time we are calling a function, next time it is being called on n minus 1 values. Okay. So what would be our recursive approach? Let me write down here. So this would be our recursive function, int n and int k. So you know, if n equal to 1, anyway 0 index value, only one node would be there, right? So the index 0 would be our answer. Otherwise, what will happen? We would be basically calling n minus 1 function. Okay, our node would become n minus 1 and k is still there. So I have made plus k here. Okay, plus k %n. Now I will tell you why I am blindly putting this plus k. So there is a reason behind it. So let me explain that. So you guys know when we started from 0, we were counting here 1 until k. So in this case at 2, it was becoming like k. So we are supposed to delete this guy. Okay. So if we delete this guy, what will happen? We would be having this kind of thing. This guy would be directly connected to this thing, right? So this would be something like this directly connected, right? Now you tell me one thing. See here, once when we are again calling this function, we will start from here, right? Now this function, whenever we are calling something, that is considered as 0 indexed. But after doing the k removal operation, our initially this guy was at 2 index, right? Its value is 2 only, right? But after doing this deletion, we are calling this function from here, and whenever we are calling from anywhere, that point is considered as the 0 in our assumption, correct? So now you can say the index which was earlier 2, okay, if we go so we already removed the 2 minus k, right? So k is 2, so 2 minus k, it is becoming 0. So we can say that in the modified way, the actual indexing is being reduced by minus k, correct? It is reduced by minus k because I am calling at 2. Initially it was index 2, but now after deleting the kth element, I am calling the function from 2. Okay, so it should be at 0 indexed. So that means 2 minus k would be giving us, that is why. So when we are calling from here, it should be considered as 0's indexed. So to nullify this in the actual 0 indexed form, I am making a plus to this. Okay, so plus k, because it is decreased by minus k and we need the original indexed. So that is why I am making a plus k, and then I am making mod n. So this mod n only to stop the outflow from the range of n, right? So that is only for that. So initially it will call internally similarly, and when it will reach to 1, then we will go to this closing condition, right? It would be returning 0, but this might be returning some other value, but it would be 0. But because of this plus k, we will get the actual index in our 0 index system, like 0, 1, 2, 3, 4. So that is why we are making this plus k. Similarly, like, right, if we go 2 step towards something, that means it is 2 less than, correct? If something is at distance 10 step, if we move 2 step towards it, it would be 8 step away, right? So for same reason I am doing this way. Now I would be showing the both solutions, the Qbased code as well as this code, and I'll tell you what is the difference between them. So let me go to directly my code part. So let's first check to our Qbased solution. Okay. So what I'm doing here, I'm creating a DQ, okay, double-ended queue. Then I'm first of all I'm putting all the numbers starting from 1 to n into that queue. Okay. Then I'm making this for loop, and what I'm doing, I'm k minus 1 elements I'm removing from the queue and adding that queue to the end of it. Okay. And the kth element I am removing at line number 15, and I am repeating this process until the queue size become 1. Okay, so then we will come out of this queue and I am returning that peak value. Okay, so let me execute this code first. So see here, I am calling the Qbased solution. Yeah, so let me submit it. It is working fine. Let me submit it. Now you can see this is faster only than 23% people's, right? That means this code must not be the best code, because it is taking O of n square, n into k basically, which is n square only in general terms. So this is not the most efficient algorithm, but we should definitely know it. Now I will show you what is my second approach, the one we've just explained. So see here, this is my util method, where if n equal to 1, then I'm returning 0, because we are here taking care of the 0 index system. Okay, so if n is equal to only 1, that means return 0. That should be our solution. Otherwise we are calling it n minus 1 every time on the k system, and then making plus k and %n to avoid any outflow. Okay, then I'm returning, so it will internally call, keep on calling until this part, first parameter becomes 1. Okay, then it would be returning 0 there. Then there would be a number, multiple k's would be added there. That will give the exact index for us. Okay, so now let me run this code. I'm commenting out Qbased solution and removing the comment of it. So let me run it. So let me submit it. So see here, this is 100% faster. So that is why we should approach this problem with the second approach, but we also should know how to solve it with the Qbased approach. So thank you for watching the video. If you have any concern, please make a comment over there.